Next, any other doubts?
I have from HCV, but then
Okay,
uh,
tell me which question.
I have doubt in small bits of the questions, sir.
Hmm.
Third, 11th one.
Consider a cold nucleus to be a sphere of.
Only the last statement.
Why do these protons not fly apart under this repulsion? Where are protons?
In the nucleus.
So the question is, why are protons not running away in the nucleus? From the nucleus,
Yes, sir.
right? All protons have positive charges. Then why protons are not running away from the nucleus? Due to the electrostatic force. Because there are nuclear forces. There is something holding the nucleus, right?
Yes, sir.
I mean, there is a chapter called nucleus, which we do in modern physics. But because that fellow has put that statement over here in a generalized way, I'm discussing that in nucleus, if electrostatic force was so dominating, we wouldn't have had something called nucleus. We have something called
Yes.
nucleus because the nuclear forces are dominating. How can I say that? Because something is holding all these protons together, right?
Yes, sir.
Otherwise, science doesn't tell magic. If there are positive charges all sitting together, then those positive charges have to, if they are free to move, they will definitely run away. If I have 10 positive charges, all free to move, placed nearby each other, everybody will run away to infinity. No doubt in that.
Yes, sir.
If they are not running away, somebody is binding it. I used a very generalized word, but in nucleus chapter, binding energy is a proper word, proper definition. Anyways, so that's the reason. Yeah. Binding energy is a physical quantity. Yeah.
15th B bit.
Good. I also got doubt in this when I first solved it. Suppose blah 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 and the repulsive force between protons is just balanced by the attractive nuclear force. When the separation is this, find the value of C. So this force that he has given is equal to electrostatic force, right?
Yes, sir.
Electric force. So KQ1 Q2 by R square is equal to whatever force he has given.
Yes, sir.
So what is the doubt in this? We simply have to equate
Yes, sir.
KQ1 Q2 by R square is equal to so and so. Whatever force he has given. You can solve it later.
Yes, sir. Okay.
Next. By the way, divided by R square is basically whole divided by R square. Okay. I mean, when the first time when I was solving, I got confused with that term. C e to the power minus kr, that entire thing is divided by R square. Okay.
Yes, sir.
Next.
23rd, I was getting minus tension. Because I was getting tension. 1 second.
23rd, you should not have a doubt at all, I think. We have solved those questions. Yeah.
There I'm getting magnitude is same only, but I'm getting negative of tension.
How can you get negative?
There because T sin theta component and the electrostatic force component are in the same direction.
T cos theta is equal to mg and T sin theta is equal to electrostatic force.
1 second. Yes sir. T sin theta and mg are in same direction.
Yeah? Are in same direction.
They're because they're what? Did I say what?
Are in same direction. That's why my English is weak. What? T cos theta, T sin theta are in same direction.
Yes sir.
When you take...
I'm telling T sin theta and electrostatic force.
That is fine. So, are in same direction. T sin theta and electrostatic force.
Yes sir.
Then who is cancelling the horizontal direction force? That means the charge will run away in horizontal direction, right? I'll draw the diagram. I think you made mistake in diagram. So I'm assuming it's positive charge, whatever, but this is our tension, this is our electrostatic force, and this is our mg.
The tension, shouldn't it be in the other side?
This is for the left side. For the right ball, we will have electrostatic force.
They are separated by a distance and
if there are
5 meters, it's held at the ends of the 5 meter, and they told that if the distance between them is 3 meters, then they are in equilibrium.
Okay.
So they are brought together.
Two identical are charged by blah blah. Okay, so basically we have one, both are not positive charges. One is positive, other is negative.
Oh.
They are rubbed with each other. So in that case, what will happen is our string basically will look like this.
Then Fe will be in other direction. So I took both positive charges only.
They are rubbed against each other and charged means charge is conserved, right? When I rub it, if plus 20 coulomb is here, minus 20 coulomb should be on the other surface.
Yes, sir.
Next.
I forgot I have to tell some. Sir, then it should attract, no, sir, like if there's a positive and negative charge. But why is it in equilibrium, like at certain distance?
Equilibrium has nothing to do with force of attraction or repulsion. Equilibrium is net force is zero. So I already drew this diagram that when there is force of attraction, both the charges will come closer to each other.
Yes, sir.
Then this tension will act here, gravitational force is here, and electrostatic force for this is here. Similarly, the tension is here, electrostatic force for this is here, and gravitational force is here. This is the distance between the upper ends of the string, whereas this is the distance between the charges, which you were saying 3 centimeter separation.
Yes, sir.
This is the figure for that question.
Yes, sir. I didn't take positive, negative, so I didn't.
Draw this figure in your rough.
I drew the same thing only, but yes, sir.
So that you don't confuse yourself when you're solving again. So you can take anything. This has plus q, this has minus q. That's it.
Yes, sir.
After this, you can take the components and.
Yes, sir.
But my confusion was, you said T you got as negative.
Yes, sir.
So my confusion is, not physics. My confusion is mathematics.
Yes, sir.
Suppose you have t sine theta is equal to a, and suppose you have t cos theta is equal to minus b. Let us say,
Yes, sir.
suppose. Eventually, to get tension, I have to do t is equal to under root of a square plus minus b whole square, which is b square.
Yes, sir.
I don't know how I can get negative from here.
I didn't do like that, sir. I found sine theta.
Okay. You found cos theta, then substituted here, then you got t as
Yes,
net.
sir.
Okay. Should I erase?
Yes, sir.
Next.
28.
28.
Sir, that calculation is becoming so lengthy, I don't know what to do.
Two identically charged particles. So, what is the problem that you're facing here?
Sir, now, if it moves small displacement, then the spring force and the electrostatic force will be balanced, right? So I took 10 centimeter plus x,
Okay.
and I'm solving.
Also, sorry.
I'm solving for x, sir, but then I'm not x. I mean, it's becoming a
Big.
lengthy calculation.
That's
Yes.
why he wrote take x as less, very much less than 10. Because when you have quadratic, you can neglect x square term and it becomes very easy.
Yes, sir.
That's it.
Okay.
While solving, you will have 10 plus x whole square in the denominator. So there you can neglect the x square term if x is taken very much less than 10.
Sir, in the 30th question, I'm getting wrong answers. Sir. I took
Particle A having a charge of and mass is placed at the bottom of a smooth inclined plane. Where should another particle having same charge be placed so that it remains in equilibrium?
Sir, I took mg sine theta equal to Fe.
So simply, yeah, correct. Mg sin theta is equal to Fe.
Then I'm
But yeah, that is correct only.
OB square that I found out. Sir, in the 37th,
Hmm.
sir, suspended in the sense like it is not suspended with any thread or something, right?
Suspended is basically it's just in air, mid-air. Just like a magic show, something is floating.
Yes, sir.
But why would it float? I mean, conceptually. In this question, why would it float?
Something should balance something, sir.
Correct. So why should it actually not float? Let's look at it in a reverse way. Why should a water droplet not float in atmosphere or whatever?
Maybe due to atmospheric friction. I don't know.
I'll repeat my question. Why are water droplets not floating everywhere? Why is the ocean on the surface? Why is it not floating everywhere? Imagine the world with.
Gravity, sir.
Thank you. So, the water droplet will not float in the atmosphere because there is a gravitational force. So, who is cancelling this gravitational force if it has to float?
The mass of it.
Mass is cancelling gravity.
No. Normal of it.
Nor English, of course.
There's no surface on the earth.
Which chapter are we in?
Electrostatic. Sir, I thought the same, but how can I even relate to electrostatic force, sir?
Because that fellow wrote something in the question. What is the magnitude of electric field in the room? What is its direction? That means there is electric field.
Okay.
So obviously the point is, idiot fellow, that fellow should say that there is electric field in the. Then he is like, "Arey, which chapter are we in?"
Sir, 45.
mg is equal to QE. The answer is mg.
Understood, sir. Yes.
45. Positive charge is placed in front of a conducting solid cube at a distance. Find the electric field at the center of the cube due to the charges appearing on its surface. Circle it with pencil. We'll do it in future.
Yes, sir. 52.
52.
Yes, sir.
Okay. What is the doubt in 52?
Very sorry with sir.
In first year, we have collisions.
Yes, sir.
I think it's an elastic collision, right, with the wall
Yes, sir.
in this question.
1 to 1. Yes, sir.
So in first year physics, elastic collision, it used to come back to the same height.
Yes, sir.
There we had gravitational force.
Yes, sir.
Now,
Sir, I don't know this chapter properly.
I know. I'm just giving you a glimpse of it. Maybe you'll solve, maybe we'll circle it. That's secondary. But I know that you know that for elastic collision, it will come back to the same height.
Yes, sir.
Right? So, see, in that situation for elastic collision, this fellow will go collide and again come back, and it will come back to the same height. This was the situation.
Yes, sir.
The same situation, he rotated it and gave a horizontal electrostatic force.
Yes, sir.
So both situations are same. I'm just giving you an analogy. So if I look at this question like this, basically I'm looking at this question like this.
Yes, sir.
So there's an electric field. That means there's an electrostatic force instead of gravitational force. I have an electrostatic force. He gave E is equal to 1. So as soon as it will collide again, it will come back to the same position.
Yes, sir.
Now, we can use conservation of energy to find what is the kinetic energy over here.
elastic thing, kinetic energy is concerned.
Yes. See, that much physics, I don't know. You know. No, that is correct. So, my point is you can find velocity, right?
Yes, sir.
You can use v is equal to u plus a to find time if it is asked like that.
Yes, sir.
You can get everything from here. Only we have to think of is conservation of energy, and you will get everything else.
Yes, sir.
And I know why I took this example is I know that even in reality, we have this experience of that ball, right? Some ball, ping pong ball, whatever. It comes to the same height. If you just leave it, it comes to the same height.
With this possibility of going up.
Sometimes, yes, because of that material. But you know that it comes to the same height,
Yes, sir.
right?
Yes, sir.
That's exactly what is happening here. Now you know all the physical quantities. You know the final velocity. You know the time taken. Whatever physical quantity is needed, you know all those things. What I'm saying is now you can imagine also what is happening here.
Yes, sir. No, sir. How will the block go back? Hit the. How will the block hit the wall again, sir?
Because why will, in this case, why will the ball again go back to hit the ground?
Where gravity is there, here nothing is there, sir.
Here nothing is there. Okay. Let's remove that chapter name also, right?
Sir.
Here we have Q into E, electrostatic force.
Okay. Yes, sir.
Nothing is there. Hi guys, I hope you enjoyed the session. If you think this video was useful, don't forget to like, share and subscribe to my channel. Also, I'll be waiting for your comments in the comment section. See you in the next video.